Have you ever played a video game and wondered how those amazing characters and environments come to life? The answer is 3D modeling. 3D modeling is the process of creating three-dimensional objects using specialized software. These models are what populate our favorite game worlds, from the heroes we play as to the environments we explore. It's a fascinating field that combines technical skill with artistic vision. Imagine building a toy house with blocks. 3D modeling is similar, but we use digital tools and techniques to create anything imaginable. This guide will take you on a journey through the world of 3D modeling, covering everything from the initial concept to bringing your creations into a game engine. Whether you're a complete beginner or have some experience, this guide will provide you with the knowledge and confidence to start creating your own 3D game models. Get ready to unleash your creativity and dive into the exciting world of game art. Before you jump into the exciting world of 3D modeling, it's crucial to have a plan. Imagine building a house without a blueprint chaos, right? The same applies to 3D modeling. This planning phase is called pre-production. It starts with an idea, a vision of what you want to create. This is where concept art comes in. Concept artists create sketches and paintings that capture the look and feel of the game world and its inhabitants. These sketches serve as a visual guide for the 3D modelers. Next, we have the modeling brief. This document outlines the specific requirements for the model, including its size, shape, and level of detail. Think of it as a set of instructions for the modeler, ensuring everyone is on the same page. Finally, we gather reference images. These are photos or drawings of real-world objects that resemble the model you want to create. They act as visual aids, helping you understand the forms and details of your subject. Now let's start building, but instead of clay or wood, we use polygons. Polygons are the building blocks of 3D models. Think of them as digital pieces of paper that we connect to create a three-dimensional shape. This process is called low-poly modeling. In games, we use something called real-time rendering, which means the computer has to draw the entire scene dozens of times every second to create the illusion of movement. This is where low-poly modeling comes in. Low-poly models use a smaller number of polygons, making them less computationally expensive to render. Imagine trying to run a marathon carrying a heavy backpack versus a light one. The heavy backpack represents a high-poly model, while the light one represents a low-poly model. Low-poly modeling allows games to run smoothly on a wide range of hardware, from powerful gaming PCs to mobile phones. It's all about finding the right balance between visual fidelity and performance. We've built our low-poly model, but our work isn't done yet. We need to optimize it for real-time rendering. This means making sure it runs smoothly in the game engine without any hiccups. One important technique is baking. Imagine baking a cake. You mix all the ingredients, but the real magic happens in the oven. Baking in 3D modeling is similar. We use special software to bake the details from a high-poly model onto the low-poly one. This creates the illusion of high detail while maintaining a low polygon count. Clever, right? Another crucial aspect is level of detail, LOD. Imagine looking at a building from afar. You don't see every brick and window, right? LODs work similarly. We create multiple versions of the same model with varying levels of detail. The game engine then displays the appropriate LOD based on the distance from the camera. This further improves performance by reducing the number of polygons being rendered. Section 5, Wrapping it up, UV unwrapping, explained. Our model now has a solid foundation, but it looks a bit bland, like a blank canvas. To add color and texture, we need to understand UV unwrapping. Imagine wrapping a present. You carefully unfold the wrapping paper to create a flat surface. UV unwrapping is similar. We take our three-dimensional model and unwrap its surface onto a two-dimensional plane. This two-dimensional representation is called a UV map. The UV map acts as a guide for applying textures. Think of it as a paint-by-numbers system for three-dimensional models. Each section of the UV map corresponds to a specific area on the three-dimensional model. By carefully unwrapping our model and creating a clean UV map, we ensure that textures are applied correctly and without distortion. It's a crucial step in the texturing process and requires patience and precision. Section 6, adding color and texture, texturing and materials. Now comes the fun part, adding color and texture. We've created our UV map, and now it's time to bring our model to life with textures and materials. Imagine painting on a real-life object. Textures are like digital paint, adding color, detail, and realism to our three-dimensional models. We use image editing software to create these textures. These images are then applied to the UV map, wrapping them around the three-dimensional model. Materials take texturing a step further. They define how light interacts with the surface of our model. Is it shiny or matte? Does it reflect light? Materials add depth and realism to our textures. However, we need to keep in mind that different game engines have different requirements for textures and materials. Some engines might have limitations on texture size or the complexity of materials. It's important to be mindful of these limitations during the creation process to ensure compatibility with our target game engine. Section 7. Shaping your world 3D modeling techniques. Just like a sculptor uses different tools to shape clay, three-dimensional modelers use various techniques to create their masterpieces. Let's explore some of these techniques. Poly by poly modeling is like building with digital Lego bricks. We extrude and manipulate individual polygons to create the desired shape. It's a very precise technique, often used for creating hard surface objects like buildings and vehicles. Box modeling is another popular technique. We start with a simple shape, like a cube or a sphere, and then extrude, scale, and manipulate its faces to create the desired form. Think of it like sculpting with digital clay. Sculpting is similar to working with real clay. We use special brushes and tools to push, pull, and shape the surface of our model. It's an intuitive and artistic technique, often used for creating organic shapes like characters and creatures. Finally, we have retopology. Imagine taking a messy ball of yarn and carefully rewinding it into a neat, organized spool. Retopology is similar. We take a high poly model, often created through sculpting, and create a clean, low poly version on top of it. This ensures that our model has good topology, making it easier to animate and deform. Section 8. Game engine limits, working within the boundaries. We've explored the exciting world of 3D modeling, but there's one crucial aspect we need to keep in mind: game engine limitations. Think of a game engine as the stage where our 3D models come to life. Each engine has its own set of rules and limitations that we need to be aware of. One important factor is polygon count. We've already discussed the importance of low poly modeling for game performance. Game engines often have limits on the number of polygons a single model can have. Texture size is another limitation. Game engines have restrictions on the resolution of textures we can use. Larger textures require more memory, which can impact performance. Materials and shaders also have their limits. Some game engines might not support certain types of materials or shaders. Finally, we need to consider physics and collision. These aspects determine how our models interact with the game world. We need to ensure that our models are set up correctly to avoid any glitches or unexpected behavior. Section 9. Your digital toolkit, essential software for 3D modeling. Ready to start your 3D modeling journey? You'll need the right tools for the job. Thankfully, there are many fantastic 3D modeling and game development software options available. Let's explore some popular choices. For 3D modeling, industry giants like Autodesk, 3Deciseconds, Max, and Maya dominate. These powerful software suites are known for their robust features and are widely used in professional game development studios. Blender is another excellent option, especially for beginners. It's a free and open source software that offers a comprehensive set of tools for modeling, sculpting, texturing, and even animation. When it comes to game engines, Unity and Unreal Engine reign supreme. Unity, known for its user-friendliness and versatility, is a great choice for beginners. Unreal Engine, on the other hand, is favored for its stunning graphics and powerful features, making it ideal for high-end game development. Choosing the right software depends on your budget, experience level, and the specific requirements of your project. Section 10. Top tips for success, best practices for 3D modeling. Embarking on the 3D modeling journey can be exciting and challenging. To help you on your path to becoming a proficient 3D modeler, here are some valuable tips and best practices to keep in mind. Simplicity is key, especially when starting. Begin with simple shapes and gradually add complexity as you gain confidence. Avoid over-detailing early on, as it can make the modeling process overwhelming. Reference images are your best friends. Gather as many visual references as possible for the object you're modeling. Use them to understand the forms, proportions, and details of your subject. Don't be afraid to experiment and make mistakes. Iteration is a crucial part of the learning process. Test your models in the game engine frequently to identify and fix any issues early on. Collaboration is key, especially in game development. Communicate with the developers and artists on your team, share your progress, and be open to feedback. Remember, game development is a team effort. Section 11. Conclusion: your journey into the world of game art. Congratulations on taking your first steps into the exciting world of 3D modeling for games. Remember, the journey of 1,000 miles begins with a single step. Don't be discouraged if your early models don't look like masterpieces. Every professional 3D artist started right where you are now, eager to learn and passionate about creating. The key is to never stop learning and practicing. Explore different software, experiment with various techniques, and challenge yourself to create new and exciting models. Embrace the iterative process, don't be afraid to make mistakes, and most importantly, have fun along the way. The world of 3D modeling is vast and ever-evolving, offering endless opportunities for creativity and innovation. So go forth, unleash your imagination, and bring your game ideas to life.